Hello, children. Welcome to the live session. Today, we are going to deal with a very important topic, that is some applications of trigonometry, class 10 CBSE. The concept is very, very important. It's a continuation of the previous chapter, children, that is nothing but the ratios of trigonometry and the standard angles of trigonometry. I hope so. You have learned those concepts and you are thorough with the standard angles, because in this chapter we are using the standard angles as well. Clear? Okay. So let me wait for some more time. Let others also join. I'll be able to see who all have joined the session. So it's a live session, children, where we are solving the complete exercise of some applications of trigonometry. Definitely, the chapter is very important and it carries a certain good marks in your board examination. Let me check whether I am live or not, just for the confirmation. Yes, children, I hope so. I'm audible, so I'll be able to see the comments, whatever you are doing. Okay. Yes. Now let's not delay. The concept says some applications of trigonometry. You must know what are the trigonometric ratios. Let me very quickly revise what are trigonometric ratios. Clear, children? Right. So first of all, we know that there are 6 trigonometric ratios. That is, look at this triangle over here. The trigonometric ratios are applicable to the right angled triangle, children. So in the triangle ABC, AB is a side of a right angle, BC is a side of a right angle, and right angled triangle, angle B is 90 degree. The side opposite to 90 degree is called as hypotenuse. So basically we have sine theta. If this is the angle theta, which is acute angle, sine theta is given by the ratio perpendicular by hypotenuse. Okay, so then we have cos theta, that is nothing but base by hypotenuse. Then we have tan theta, that is perpendicular by base. Clear, children? So you must know the reciprocal ratios also, right? So sine and cosecant, these are reciprocal ratios. Okay, they are reciprocals of each other. Then cos and sec are reciprocal of each other. Cos theta and sec theta, sin theta and cosec theta, then tan theta and cot theta. They are also reciprocals of each other. You must know what you mean by reciprocal ratios. Okay, so reciprocal means, suppose for example, if I have 5 by 2, if I want to reciprocate it, okay, reciprocal of 5 by 2 is written by 2 by 5. So here I can say sin theta is same as 1 by cosec theta, or cosec theta is equal to 1 by sin theta. That is the meaning of reciprocal. Clear, children? So similarly, cos theta is equal to 1 by sec theta, or sec theta is equal to 1 by cos theta. That is the meaning of reciprocal. Right. Similarly, I can say tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan theta. That's how I say they are reciprocal of each other. But many of you get confused that how to remember this. Okay, how to remember sine is what, how to remember cos is what, how to remember tan. So how can I remember that sine is perpendicular by hypotenuse, how to remember that cos is base by hypotenuse, how to remember that tan is perpendicular by base. So very simple thing, simple trick I will tell you to remember this, children. Keep in mind that sine is perpendicular by hypotenuse. Clear? Cos is what is cos? What is cos, children? That is nothing but base by hypotenuse. Right? So then tan is perpendicular by base. So sine is perpendicular by hypotenuse, cos is base by hypotenuse, and tan is perpendicular by base. So how do you remember this one? You just remember sine as a, look at this, some people have, see, sine is nothing but perpendicular by hypotenuse. Then you can easily remember sine. So to remember cos, curly brown hair. Okay, curly brown hair. Cos is a base by hypotenuse. Then to remember tan, you can remember it as a tightly pulled back. Okay, so tightly pulled back. Tan is nothing but a perpendicular by base. Okay, so if you remember sine, right, so you can easily write down what is cosec. Cosec is going to be reciprocal of sine. Cosec is going to be hypotenuse by perpendicular because it is perpendicular by hypotenuse. Then sec is going to be hypotenuse by base because cos is base by hypotenuse. Then tan is going to be base by perpendicular, cot is going to be base by perpendicular because tan is perpendicular by base. Clear, children? Very easy to remember, right? And also you must know some of the standard angles over here. The standard angles are 0 degree, then 30 degree, then 45 degree, 60 degree, 90 degree. So whatever we are discussing now, they are nothing but the prerequisites for the chapter heights and distance. These are the concepts what you must know before you start studying the heights and distances. That is some applications of trigonometry, right, children? So again over here I told you to remember the sine, cos, tan. If you remember only these three, you can easily recall the rest of them. You can easily recall the rest of them. See, how can you remember sine, cos, and tan, children? You must remember, look at this very clearly, very simple way to remember. Pay attention, children. So just remember sine, you can easily recall cos. You remember tan, you can easily recall cot. Then you can remember cos to recall the cosec, and similarly all other reciprocal ratios. Clear, children? So now see sine 0, you can just remember it like a square root of 0 by 4, square root of 1 by 4, square root of 2 by 4, square root of 3 by 4, and square root of 4 by 4. Clear, children? Square root of 0 by 4, square root of 0, 0 divided by anything is 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So here square root of 2 by 4 I have written 2 ones are 2 twos are, I'll get it as square root of 1 by root 2. Then over here sine 60 is square root of 3 by 4, square root of 3, which is not a perfect square, right? Square root of 4 is 2, so root 3 by 2, right? Square root of 4 by 4, 0, 1 ones are get cancelled, then square root of 1 is 1 itself. So you know that sine and cos are complement of each other. Whatever you have written for the sine, you just take the u-turn and come back for the cos. See, sine is over here, cos is over here. Whatever you have written for the sine, just take the u-turn and come back. So whatever you have written over here, you write it in the reverse order. So 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. That will become cos. Now sine, you know that sine divided by cos is equal to tan. Clear children? So I will divide this by this to get the ratio of tan. Okay, so tan 0 is 0, tan 30 is 1 by root 3, then this is going to be 1, then this is root 3, then this is not defined, or you can always say that it is nothing but infinity. You can also say that it is infinity. Clear children? Okay, so only these three ratios are required a lot. Okay, these ratios are required, okay, to learn the concept of the heights and distances. Clear children? Okay, so now please pay attention children. We are moving on to the concept that is heights and distances. All right, that is nothing but the some applications of trigonometry. What are the applications of trigonometry? Now pay attention children, look at this. Now suppose you are standing somewhere over here, say for example it is you, okay, who is standing over here, right? And you are so comfortable to watch front. Okay, so you are so comfortable to look at your straight path. This is called as your horizontal plane. This is called as your horizontal plane. Just imagine that you are standing in the balcony of your house and you are watching a aeroplane which is flying above your head. Right? How do you watch the aeroplane which is flying above your head, children? You will watch the aeroplane which is flying over here. This is your aeroplane. Okay, so this is your aeroplane, right? So whenever you are watching a aeroplane which is flying above your head, you are making certain angle with the horizontal plane. You are making certain angle with the horizontal plane. This angle, say for example, if I call this angle, that angle is called as a angle of elevation. The angle which is formed above the horizontal plane is called as an angle of elevation. Now you are asked to call your brother which is who is playing down. You are staying in the balcony of your house, children. All right, just imagine you are watching a aeroplane over here, right? You are raising your neck, the angle of elevation is formed over there. Now your mom is asking, okay, call your brother who is playing downstairs. Then you look downward, then you see your brother with certain angle, with the angle which is made over here with a horizontal plane, that is nothing but, say for example, if I call it as alpha. All right, the angle made between the horizontal plane and the line of sight, okay, just below the horizontal plane is called as an angle of depression. It is called as an angle of depression. Children, keep in mind the angle made between the line of sight and the horizontal plane is called as angle of elevation, and the angle made between the line of sight and the horizontal plane is called as a angle of depression. Clear children? Right, so you don't want to watch the movies sitting right in front of the screen, correct children? All right, because if you are sitting right in front of the screen, your horizontal plane is this, your angle of elevation will be too high, you definitely get the neck pain. So you are not so comfortable watching a movie sitting right in front of the screen, right? You want to have certain distance so that the angle of elevation is reduced, so it is almost equal to the horizontal plane. You will feel so comfortable to watch the movie sitting far away from the screen. Clear? Right, so you must understand what is horizontal plane, what is line of sight, what is angle of elevation, and what is angle of depression. Say for example, I'll give you a simple example, children. Look at the screen very carefully. Suppose a boy is standing at a distance of 4 meter away from the foot of a tower. Away from the foot of a tower. Right, here is the boy. I just call the position of the boy as C, the height of the tower as AB. Right. So now, if he is watching the tip of a tower with an angle of elevation of 60 degree, find the height of the tower is the question. Find the height of the tower is the question. So now, how can I apply the concepts of heights and distances or some applications of the trigonometry over here? Need to understand, children. So I need to find out AB, which is nothing but the perpendicular to the boy, right? And the base is given to you, which is nothing but CB. You need to take the ratio which involves perpendicular and the base. So what is the ratio which involves perpendicular and base? That is nothing but a tan. Clear, children? So I told you tightly pulled back. So tan is perpendicular by base. So tan of this angle, right? Tan C in the triangle ABC. Tan C is equal to AB divided by BC. I will write. Clear, children? What is the tan C? That is nothing but tan of 60 degree is equal to AB, which is not known to us, which has to be found out, and BC. Okay, so I can write BC as a 4 meter. I can directly write in this step itself. So BC is equal to 4 meter. I'll just write in place of BC. I'll write it as 4 meter. Clear, children? You know that what is tan 60? Tan 60 is a root 3. Root 3 is equal to AB by 4. So what I get? AB is equal to 4 root 3 meter. Clear? Sometimes what happens? Right. They may ask you to substitute root 3 as 1.73. Root 3 is equal to 1.732. In fact, they may ask you to substitute root 3 as 1.732. So that time you need to write 4 into 1.732 and write down the answer. That is 4 2s are 8, 4 3s are 12, then 28, 29, then this much meter is the height of the tower, you can say. Clear, children? Right. So sometimes what they may give the question like a boy standing at a height of 8 meter from the ground observes an car with the angle of depression of 30 degrees. See this is, children, this is nothing but the horizontal plane. This is nothing but the horizontal plane. The boy is over here, the car is over here, this is nothing but the ground. Clear, children? Right. He observes the a car which is there on the ground with the angle of depression of 30 degrees. See, always keep in mind whether you are talking about angle of elevation or you are talking about angle of depression. Okay, if you are talking about angle of elevation or you are talking about angle of depression, it is always the angle between horizontal plane and the line of sight. Keep in mind, line of sight. Why I am telling you this, children? Many of you do a mistake of taking the angle of depression over here. Okay, you will end up saying that this is the angle of depression. No, this is not the angle of depression. Angle of depression is the angle between the horizontal plane and the line of sight. This is the angle of depression, not this. Clear, children? Right, this is not the angle of depression. Keep in mind, right? If you take that as angle of depression, angle of depression as the angle between the line of sight and the tower over here, you definitely go wrong. Clear? Angle of depression is always the angle between the horizontal plane and line of sight. Now If you observe carefully, this line and this line are parallel to each other. So this angle is equal to this angle because they form a interior alternate angle. Children, understood? Comment and let me know whether you are following or not. Yes. Okay, so good evening children. I'm seeing your chats. Let me know. Right, please ask your friends to join. Right, so this is the interior alternate angle. So over here, if it is 30 degree, and this also is going to be 30 degree. Clear children? Interior alternate angle. Now I will name this angle A, B, C as the sides. The question I'm giving you just example. We have not yet started with the concept, children. Keep in mind. I'm just giving you an example over here. Clear children? Okay. So the question says a boy standing at the distance of above the tower, which is 8 meter high, observes a car with the angle of depression of 30 degree. Find the distance between the foot of the tower and the car. In the sense, you are asked to find out how much is this. Clear children? Okay, so now again, this is the angle. For this angle, this is nothing but the opposite and this is nothing but the base. Clear? I need to take the ratio which involved perpendicular and a base, or opposite and a base. Clear children? Okay, so now I can say tan of 30 degree is equal to AB divided by BC. So tan 30 is how much? It is 1 by root 3. AB is how much? 8 meter divided by BC. So BC is equal to 8 root 3 meter. Okay, so you can say that a car is at a distance of 8 root 3 meter from the foot of the tower. From the foot of the tower. Clear children? I hope so it is clear. So very important points whenever you are dealing with a concept, some application of trigonometry. The important points what you need to keep in mind is very first thing is what? Locate the observer. Okay, locate the observer. Where is the observer? I'm telling that the observer is standing on the top of a 8 meter high building. Okay, so observer is over here. If you locate the observer over here, you are wrong, children. Keep in mind that observer is over here. Locate the observer. Okay, then second one is what, children? Draw the horizontal plane from the observer. Okay, so this is the very next thing. Draw the horizontal plane of the observer. You are locating the observer and you are drawing the horizontal plane of the observer, and identify the right angled triangle. Okay, identify the right angled triangle. Right angled triangle. That is your second task, one what you need to remember. Okay, so whenever I'm dealing with the concepts, that is some applications of trigonometry, first of all you need to locate the observer after drawing. Okay, after drawing the correct figure. Okay, you need to draw the correct figure first of all. Right, then locate the observer, draw the horizontal plane of the observer, identify the right angled triangles. Okay, these are the things what you need to remember. Okay, if you remember this one, you never go wrong, and you need to remember the standard angles of at least sine, cos and tan. Clear children? Sine, cos and tan you need to remember. Clear children? I hope so it is clear with you what is some applications of trigonometry. Now we are going to take up the exercises. Keep in mind, children. Okay, so observe the very first question. Observe the very first question. Now the question says that a circus artist is climbing a 20-meter long rope, okay, which is tightly stretched and tied from a top of a vertical pole of the ground. Find the height of the pole if the angle made by the rope with the ground level is a 30 degree. Now pay attention children. Here what is given to you? A person is there. He is climbing a 20-meter rope. All right. The angle made between the rope and the point where it is tied is 30 degrees. So this is nothing but the line of sight. Clear? This is nothing but the horizontal plane of the observer. You can say the observer is over here now. Clear children? So now you are asked to find the height of the pole. So you are asked to find out what is the length of AB. What is the length of AB? So again for this angle, it is an acute angle. The perpendicular is involved and over here hypotenuse is involved. You are supposed to choose the ratio which involves perpendicular and the hypotenuse. Clear children? Okay, so in triangle ABC, angle B is equal to 90 degree. So what is the ratio which involves perpendicular and the hypotenuse children? You know that some people have curly brown hair tightly pulled back. Okay, so perpendicular and hypotenuse. Okay, right. So that is nothing but the sine. So I can say that sine of 30 degree is equal to AB divided by AC. I'm supposed to find out the height of the pole. In the sense AB I'm supposed to find out. So sine 30 is what? Sine 30 is how much children? It is 1 by 2. Then AB we are supposed to find out. I don't know what is AB, so I'm keeping it as it is. Then AC is a 20 meter. So when I cross multiply, I get AB is equal to 20 divided by 2. So that is nothing but 10 meter. So you can write the conclusion that height of the tower, okay, height of the pole is equal to 10 meter. That is supposed to be your answer. Is that clear children? Okay, now let us move to the next one. Very important thing children. See over here what is given. A tree breaks due to a storm. A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree. So there's a tree over here. Pay attention children. This is a tree. They won't give you the data like a tree is making a 90 degree with the ground and all. They don't give. It is understood that whenever there is a tree, it is understood that the tree is making a 90 degree with the ground. This is the tree which is making 90 degree with the ground. A tree is broken due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree. Pay attention children. So now here, say for example, the broken part is over here. It is broken at this height. So now I just call this as a AB is the total height of the tree. Now the tree is broken at this point somewhere. Then whenever it is broken down, this part is falling down and touching the ground. Look at this. This is touching the ground. Okay. The broken part is making angle of 30 degree with the ground. This is nothing but the 30 degree. It is making 30 degree with the ground. Clear children? Right. So what is asked over there? Find the distance between the foot of the tree to the point where the top touches the ground. And okay, height of the tree you are supposed to find out. If the distance is 8 meter, here the tip of the tree, the foot of the tree is over here, the broken part is touching the ground so that the top of the tree is touching the ground at a distance of 8 meter from the foot of the tree. Okay, so you are asked to find out the height of the tree. So height of the tree is what children here? So first of all, what is the total height of tree? Height of tree is BC plus CA. So that will give you the height of the tree. So I'm supposed to find out BC as well as CA here to find out the height of the tree. Clear, children? So you can just comment hi, okay, in the comment box, children. Let me know whether you are actually listening or not. Okay. So now in triangle ABC, in triangle ABC, so angle B is equal to 90 degree. Here my task is what? My task is to find out BC as well as AC. So I need to see this point. This is the observer where he is standing now. So from this point, what is BC for this point? This angle, it is nothing but the perpendicular. Clear? So, and what is AB? AB is nothing but the base. Clear, children? Right. So now I can say that tan of 30 degree is equal to BC divided by AB. BC divided by AB. Tan 30 is how much? Tan 30 is 1 by root 3. 1 by root 3 is equal to BC, which I don't know, by AB, which is 8 meter. Clear? So if I want to find out BC, BC is equal to 8 by root 3 meter is the BC. Clear? Now I have found out BC. So I am supposed to find out AC also, because BC plus AC will give me the total height of the tree which I am asked to find out. Clear, children? So next what I do, AC is what? The hypotenuse of the triangle over here. Clear? So I am aware of what is the base. I am supposed to find out the hypotenuse. So which ratio should I take? See, curly brown hair. Clear? So means what? Cos is a base by hypotenuse. I will go ahead with the cos of 30 degree. Cos 30 degree is a base by hypotenuse. So that is nothing but AB divided by AC. Cos 30 is how much? 1 by 2. Cos 30 is same as sin 60. Sin 60 and cos 30 is root 3 by 2. Sorry, root 3 by 2. Clear, children? So now what I am getting AB as? AB is equal to 8 divided by AC I am supposed to find out. Clear, children? So can I write AC is equal to 2 into 8 divided by root 3. Okay, so AC is equal to 2 into 8 divided by root 3. That is AC is equal to 16 by root 3 I get. So that is AC what I am going to get. Clear, children? So now height of the tree is equal to height of a tree is equal to BC plus AC or CA. Right? What is BC? We have found out it as 8 by root 3. And CA, we have found it out as 16 by root 3. So here I can take LCM as root 3 itself. So 8 plus 16, that is 24 by root 3 I get. I should not keep the answer, okay, as irrational denominator. So I need to rationalize the denominator. Root 3 by root 3 I get. So I will get this one as 24 root 3 by 3. So 8, 3 ones are 3 8s are. So I can say 8 root 3 meter is nothing but the height of the tree. Clear, children? Yes or no? Please let me know. Okay, please comment and let me know whether you are following or not. Let me know. I'm observing your comment, children. If you confirm, we can proceed with the next one. Please let me know. Yes, 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 I'm seeing the comments over there. Okay, okay, right. Yes, now it is clear till here. Now let me take the next concept. See here, next question. A contractor plans to install 2 slides for children to play in a park. For a children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter, inclined at an angle of 30 degree to the ground, whereas the elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? Okay, so now In each case, I need to find out the length of the slide. First case, right? So children below 5 years. For the children below 5 years. For children below 5 years. Okay, that is case 1. I have taken it as. She prefers to have a slide whose top is at a height of 1.5 meter. Okay, and inclined to the angle of 30 degree to the ground. See, this is nothing but the slide over here. Okay, so A, B, C, this is nothing but the slide what is represented by the line A, C. This is always perpendicular, keep in mind. Now it says that the height is 1.5 meter. It is touching the point A over here at a height of 1.5 meter. At a height of 1.5 meter. You are asked to find out what should be the length of the slide in each case, and it is making an angle of 30 degree with the ground. Clear, children? Okay, so now please pay attention. It is making an angle of 30 degree with the ground. So I need to find out AC again. So what is AC for this angle? This is the angle over here, right? Acute angle. So what is AC to this angle? It is nothing but the hypotenuse. And what is AB to this angle? It is nothing but the opposite. Correct. So in triangle ABC, angle B is equal to 90 degree. So I need to find out the hypotenuse where the opposite is known to you. It is given to you. So I need to take, see, opposite, that is perpendicular, and hypotenuse. So some people have. So I need to go ahead with the sine again. So sine of 30 degree is equal to AB divided by AC. Sine 30 is how much? 1 by 2. Sine 30 is 1 by 2. AB is how much, children? It is 15 divided by AC. I'm supposed to find out. So what can I write over here? AC is equal to 15 into 2, that is 30 meter. So AC is equal to 30 meter I get. Clear? Right, that is the length of the slide in the first case. Later in the second case, okay, and inclined 30 degree, whereas the elder children, okay, this is for elder children. Okay, this is for elder children. The same figure, okay, is applicable over here, but the thing is what? It is 3 meter height from the ground. Okay, where the slide is touching the point A, this is 3 meter high. Okay, B and C. Right, again it is making an angle of 60 degree with the ground. You are supposed to find out the length of the slide over here. You are supposed to find out the length of the slide. Again, you must know, children, this is a perpendicular and this is nothing but the hypotenuse. What ratio? Sine itself. So again, in triangle ABC, angle B is equal to 90 degree. So that the triangle is right angle triangle. I am applying the trigonometric ratios to right angle triangle. So sine 60 is equal to AB divided by AC. Sine 60 is root 3 by 2. AB is how much? 3. AC I am supposed to find out. So what can I write over here, children? AC is equal to 3 into 2 divided by root 3. So that is nothing but 6 by root 3. As I told you, denominator should not be irrational. 6 root 3 by 3. They get cancelled. So I get AC is equal to 2 root 3 meter. Clear, children? Okay. So I'll get to know what are the lengths of the slides over here. Clear, children? Any doubt over here? Right. This is 5 year 1.5 meter. It is not 15, children. It is 1.5. When I'm taking 1.5, this is going to be 3 meter that time. Okay. 3 meter. So it is not 15. It is 3 meter. Clear, children? Any doubt over here? Right. Okay. So now let us proceed with the next one. Pay attention, children. The sixth question says that a 1.5-meter tall boy standing at some distance from a 30-meter tall building. Okay, so the boy is standing over here. I'll draw the horizontal plane first of all. Okay, so this is the position of the boy. How high the boy is? He is 1.5 meter tall. 1.5 meter. So AB represents the height of the boy. Boy is over here. Boy tall is standing at some distance from a 30-meter tall building. So he is watching a building which is 30-meter tall. So I call this as CD. So this is 30-meter, okay, tall building. The angle of elevation from his eyes to the top of a building increases from 30 degree to 60 degree as he walks towards the building. Okay, now he is standing over here. He is standing over here. What he does is, he's a naughty boy, so he will not keep at quite at same place. He'll keep on walking towards the tower. So now I will take EF, okay, as the new position of the boy. Clear, children? Right, he's observing the top of the tower, right? So now pay attention, children. First of all, he was observing the top of a tower from the original position. Okay, I'll just call this original position. Keep in mind, children, here I'll just call this as E here. First, he is observing the top of a tower with the angle of elevation of 30 degree. Clear, children? It is clearly given to you that he is 1.5 meter tall boy. This is 30 degree. Now, when he walks a distance of a certain length, now the angle of elevation changes from 30 degree to 60 degree. So this becomes 60 degree. As and then you are moving ahead of the, towards the tower, angle of elevation increases. Clear, children? So now angle of elevation increases from 30 degree to 60 degree. Find the distance he walked, okay, towards the building. You are asked to find out this distance. Clear, children? Right, so here you must know this is 90 degree. Everywhere it is 90 degree. So towards the building, pay attention, children. A 1.5 meter tall boy standing at some distance from 30-meter tall building. Okay, the angle of elevation of his eyes to the top of a building increases to 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. Clear, children? So now can I say, if I call this point as E of G, so can I say, pay attention, children, ABDG is a rectangle. It is a rectangle. So I can say AB is equal to DG is equal to 1.5 meter. So this length also becomes 1.5 meter. If this is 1.5, how much is going to be this one, children? Tell me now. This is going to be 28.5 meter because total is 30. Total is 30. 30 minus 1.5. This is going to be 28.5. You're asked to find out what is the length he walked. Means what? AE you are supposed to find out. AE is same as BF because again ABFE is going to be the rectangle. Clear? So now first I'll consider the triangle. Consider the triangle AGC. Right. So angle AGC is equal to 90 degree. Clear? Right. So I need to find out the base. I know what is the height. So I can apply tan of 30 degree is equal to GC divided by AG. GC divided by AG because tightly pulled back. Tan is perpendicular by base. Clear, children? So now tan 30 is 1 by root 3 is equal to GC is 28.5 divided by AG. We don't know how much is AG. I'll keep it as it is. So AG will give you 28.5 into root 3 meter. That is going to be AG. Clear? So next what I do? Next, consider the triangle. Consider the triangle EGC. Consider the triangle EGC, where again the angle CGE is 90 degree. Okay, so now what I do, again perpendicular is known to me and base I'm supposed to find out. Okay, so I use a tan of 60 degree is equal to GC divided by EG. Tan 60 is how much, children? It is tan 60. Tan 60 is root 3. Root 3 is equal to GC, again 28.5 divided by EC. EC is how much? Right, not EC, EG. Okay, 28.5 divided by EG. Okay, EG is going to be the base. All right, so that is nothing but the base. So I can say that EG is equal to 28.5 divided by root 3. Clear, children? So if I rationalize this, I need to rationalize the denominator. Then I can say it is 28.5 root 3 divided by 3. So 9 is 27.5 root 3 is nothing but EG. So what you're asked to find out, he walks towards the building, find the distance he walked towards the building. I'm supposed to find out AE. AE is same as PF. Okay, so distance walked by boy is equal to AE, which is same as FB, which is same as AG minus of EG. Okay, AG minus of EG. So how much is AG? I have got AG is 28.5 root 3 minus of 9.5 root 3. Clear, children? Okay, because I have found out AG as a 28.5 root 3 and EG as a 9.5 root 3. Okay, so when I do the subtraction, I'll get this one as a 19 root 3 meter is the distance walked by the boy towards the tower. Is it clear, children? Okay, are you following it? Yes or no? Please let me know by your comments whether you are following it or not. Okay, I'm waiting for your comments, children. Be quick. Let me know whether you are following or not. Let me know you are following or not. Okay, so we have found out the distance walked by the boy towards the building. Now let me go ahead with the next question. The next question says that a statue 1.6 meter tall stands on a top of a pedestal. Okay, right. So now this is the road if I take. Okay, now the statue is 1.6 meter tall. Okay, the length of the statue is given to you. Okay, on the top of the pedestal, from a point on the ground, the angle of elevation of top of the statue is a 60 degree. Okay, so now look at this here. This is the pedestal, this is the statue if I take. Okay, so I'll take A, B, right? So as the height of the statue, it is a 1.6 meter. Clear? A statue 1.6 meter tall stands on the top of a pedestal from a point on the ground. Okay, there is some point on the ground over here. I call this as a D. I call this as C. Okay, point on the ground. The angle of elevation of top of the statue is 60 degree. In the sense, children, this angle is 60 degree. If it I observe from here, the angle of elevation of this point from the point of observation is 60 degree. From the same point, the angle of elevation of top of the pedestal in the sense what, children? It is nothing but the bottom of the statue. Okay, so this is nothing but a 45 degree. 45 degree. Find the height of the pedestal. You are supposed to find out the height of the pedestal. Again, this is going to be 90 degree. I hope so the figure is clear enough. Okay, this is nothing but the statue, right? You are supposed to find out BC. So as I told you in the hint, that you need to identify the right angled triangles and you need to identify where is the observer. Clear, children? Where is observer over here? Observer is at D. Observer is at D. Clear? Okay, so he is observing the foot of the statue, that is nothing but the height of the pedestal. All right, so then that is foot of the statue is nothing but top of the pedestal, and he is observing top of the statue also, right? So there are two right angle triangles formed over here, that is ACD is one right angle triangle and BCD is another right angle triangle. So first I'll consider ACD. In triangle ACD, angle C is equal to 90 degree. Clear, children? Okay, so this is again perpendicular. What you're supposed to find out? You are supposed to find out the height of the pedestal. Any other information is given? Read the question once again clearly. A statue 1.6 meter tall stands up on the top of a pedestal from a point of the ground. Okay, on the ground, the angle of elevation of top of a statue is 60 degree, and from the same point, the angle of elevation of top of the pedestal is 45 degree. Find the height of the pedestal. Nothing else is given to you. Clear? So what I do here is, again I will write down tan of 60 degree is equal to AC divided by CD. You need to identify the right angle triangle and you need to identify the common side between the two right angled triangles. Clear? So tan 60 degree is equal to AC by CD. Tan 60 is how much? It is root 3. AC is how much? AC is nothing but AB plus BC divided by CD. So what can I write for CD, children? Okay, can I write CD is equal to AB is 1.6 meter plus of BC, which I don't know, divided by root 3. This is the expression what I get for CD. Next what I do is I will consider the triangle BCD. Okay, so in triangle BCD, tan of 45 degree is equal to BC divided by CD. So here again I get CD. What is CD? I am going to get. Let me write tan 45 is 1. BC, which I don't know, divided by CD, I'll keep as it is. Okay, so by this expression I'll get to know that CD is equal to BC. I call this as equation 2. So from 1 and 2, I need to find out what is BC. So I'll express CD in terms of BC. So from 1 and 2 I can say that BC is equal to 1.6 plus BC divided by root 3. Clear, children? I'm supposed to find out what is root 3. Yes or no? Okay, so what I do here is root 3 BC is equal to 1.6 plus of BC. What did I do over here? I have cross multiplied. So now I'll bring this BC to the other side. So I get it as root 3 BC minus of BC is equal to 1.6. Clear? So I can take out BC common and write down it as root 3 minus 1 is equal to 1.6. Clear? So BC is equal to 1.6 divided by root 3 minus 1. I cannot keep the answer with the irrational denominator. I have to rationalize this one. root 3 plus 1 by root 3 plus 1. I need to multiply both the numerator and denominator with the conjugate of the denominator. So that time I would get this one as what I would get this one as, children. So BC is equal to 1.6 root 3 plus 1 divided by root 3 the whole square minus 1 square, a plus b, a minus b. So that is equal to 1.6 root 3 plus 1 divided by 3 minus 1. So 1.6 root 3 plus 1 divided by 2. So that is nothing but 0.8 into root 3 plus 1. Clear, children? So that is what I am going to get a BC as. BC is what? That is nothing but the height of the pedestal. Clear, children? So therefore I can say height of pedestal is equal to 0.8 into root 3 plus 1. In case if they are telling that use root 3 as 1.73, you need to substitute root 3 as 1.73 and multiply that with the 0.8 and add 0.8 to it. You will get the height of the pedestal. So since they have not asked, you can keep the answer at only this point. Clear, children? Now let us move to the next one. Pay attention, children. Look at the figure over here. If the figure is given to you, that is boon in disguise for you. You need to, okay, take the best use of the figure, whatever is been given. Clear? Right. In the figure it is given, in the question it is given to you that a TV tower stands vertically on a bank of a canal. Clear? Right. From the point on the other bank directly opposite to the tower. Okay. The angle of elevation of top of a tower is 60 degree. In the sense of this is the river, children. Here a TV tower is standing. This is another bank, okay, where observer is observing the angle of uh, uh, elevation. He is observing the tip of the tower with the angle of elevation of 60 degree, and from another point 20 meter away from this point on the same line. So there is one more observer over here who is in the same line 20 meter away from the observer, okay, the initial observer. He is observing the tip of a tower with the angle of elevation of 30 degree. So 30 degree, the angle of elevation for this guy is 30 degree. Find the height of the tower and width of the canal. So you need to find out the height of the tower, this is how much, and width of the canal, that is BC is also equal to how much you are supposed to find out. Clear, children? So again I told you, identify the triangles. Which are the triangles? Clear, children? So here I have two triangles which are right angled triangle. Triangle ABC and triangle ABD. These are the two triangles. Clear, children? So in triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. Now before we proceed, let me check, children, whether you are following or not. Okay, please let me know whether you guys are following or not. Please comment and let me know. I'll wait for you guys, children. Okay, please comment quick. Are you following? Is there any problem in understanding? Let me know. Okay, yeah, angle B is 90 degree. I have considered the triangle ABC over here. So perpendicular I'm supposed to find out, and also this BC is not known to me. I'm supposed to find out that also. So I told you, please identify the right angle triangle. After identifying the right angle triangle, identify the common side, which is a common side for both the right angle triangles. Okay, so you make them as the subject of formula, right? So in triangle ABC, I can say that tan of 60 degree is equal to AB divided by BC. Tan 60 is root 3. AB divided by BC I'll keep. So I'll make AB as a subject of formula. AB is equal to root 3 BC. I will write and I will call it as equation 1. Clear, children? Okay. So next what I do, next I will consider the triangle ABD. In triangle ABD, angle B is equal to 90 degree. Clear? Okay. So later I can say tan of 30 degree is equal to AB divided by BD. So tan 30 is 1 by root 3. So AB divided by BD. BD, can I write it as DC plus BC, children? Okay, because a BD is nothing but the sum of a DC and a BC. Clear? So can I write a DC plus BC by root 3 is equal to AB. I call this as equation 2. Right. So what can I do next from 1 and 2? From 1 and 2. So I'll have this also as AB and this also as AB. Equals to equals are equal. Right. Euclid's axiom, what you learned in your 9th standard. So I can write that root 3 BC is equal to DC plus BC by root 3. Clear, children? Okay, so I am equating them, right? So now what I do, root 3 BC is equal to, how much is DC? I know it is 20 plus of BC divided by root 3. Clear? So when I take this root 3 over here, root 3 into 3, root 3 into root 3, it becomes 3. 3 BC is equal to 20 plus BC. When I take this BC to the other side, what I get, children? I'll get this one as 3 BC minus of 1 BC is equal to 20. So I say that twice of BC is equal to 20. Then BC is equal to 20 divided by 2. BC is equal to 10 meter. Okay, so what is BC? That is nothing but a width of the canal. I got to know what is the width of canal. Okay, width of canal is equal to 10 meter. Now I am supposed to find out the height of the tower. Okay, so that is AB. So next what I do, substitute BC in equation 1. So AB is equal to root 3 of BC. So that is nothing but root 3 into 10. So that is nothing but 10 root 3 meter is AB. So what is AB? That is height of the tower, children. Okay. So I can say height of tower is equal to 10 root 3 meter. Clear, children? Okay. I hope so it is clear to you. Yes or no? Okay. Now let me go to the next question, children. So the next question says that from a top of a 7-meter high building, see here, there is a building which is 7-meter high. Okay. So the angle between the building and the ground is a 90 degree. They won't say that the building is perpendicular to the ground. No, they won't say like that. Okay. It's understood that, okay, the angle between the building and the ground is 90 degree. Now from a top of 7-meter high building, okay, so means what, this is nothing but 7 meter. The angle of elevation of top of a cable tower is 60 degree. There is a tower, okay, one more tower which is again 90 degree. The angle of elevation of the top of a cable tower, this is the tower, okay, ABCD, I would call this one as angle of elevation. You are observing from here. What I told, when you are observing something, you need to draw the horizontal plane. So draw the horizontal plane. This is also 90 degree. So angle of elevation is 60 degree. Here from a top of 7-meter high building, the angle of elevation of top of a cable tower is 60 degree and the angle of depression of its foot is 45 degrees. So look at this. So whenever I am observing, this is going to be 45 degree. Okay, determine the height of the tower. So what is the height of the tower is the question. Clear? Again, I told you that identify the right angle triangles. So there are two right angle triangles. Okay, so if I call this point as AEC is one right angle triangle, also AED is one right angle triangle, and ABDE is a rectangle. That's why this also becomes a 7 meter. Okay, so I can write that one as ABDE is a rectangle. Okay, as ABDE is a rectangle, so I can say AB is equal to DE is equal to 7 meter. Also BD is equal to EE. I know this. Clear? So whichever you want to take, you can take first. Okay, so I'll take ADE. So in triangle ADE, angle E is equal to 90 degree. So I require to find out how much is AE. I know how much is ED. So again, I will go ahead with the tan. If you observe carefully, children, okay, the tan is the most oftenly used ratio. It is most oftenly used ratio. Okay, especially in the chapter Some Applications of Trigonometry. Clear? So tan of ADE I have taken. So tan of 45 degree is equal to DE divided by AE. DE divided by AE. So tan 45 is 1. DE is how much? It is 7 meter. AE I am not aware how much is. So when I cross multiply, I will get to know AE is equal to 7 meter. I have found out AE is how much. Clear? So next what I do, I will consider the triangle AEC. So in triangle AEC, again angle E is equal to 90 degree. So tan of 60 degree is equal to, can I write it as EC divided by AE, children? Because this is perpendicular and this is base. Okay, so tan 60 is how much? Root 3 is equal to EC, I don't know. AE I have found it out. Here it is 7. So therefore I can say EC is equal to 7 root 3 meter. Clear, children? So now height of the tower, right? So height of the tower is nothing but EC plus ED. EC is how much? 7 root 3. ED is 7. So if I take out 7 common, root 3 plus 1 meter. This is nothing but the height of the tower. Clear, children? Right. So now let us move to the next one. That is question number 14. Pay attention, children. So a